Assalamualaikum and good day to my lecturer, Dr. Abdul Halim bin Abdul Latif. Thank you for spending your precious time to watch my video presentation. My name is Sita Ashaina binti Ahmad Shafri and I have chosen this FQ Factory Technique as my topic for paper review presentation. Today, I will first cover on the objective for this paper review assignment, followed by the introduction, body of paper, current debate, and lastly conclusion with some recommendation for the future direction. There are three main objectives for this paper review presentation. The first one is to utilize the knowledge and understanding of FQ filtering technique in alternating the unwanted energy. The second one is to learn the difference between conventional FQ filtering and advanced FQ filtering. And the last one is to find out the current debate about the conventional and advanced FQ filtering method. Moving on to the first topic, which is an introduction. Typically, FQ filtering is defined as a pre-processing method to remove the unwanted frequency that higher or lower than seismic signal band. The seismic data that is traditionally in the time and displacement domain is converted into the frequency and width domain. The process is known as 2D Fourier transform and must be sampled according to the Nyquist criterion of aliasing. The result of 2D Fourier transform of the seismic data is known as the FQ spectrum. The purpose of FQ filtering is used for things like eliminating the aliasing surface waste energy such as ground roll, followed by attenuating the various of noise such as coherent and random noise. Lastly, FQ filtering also used to attenuate the scatter energy. The FQ filtering consists of two panels which are negative and positive panel, represented by negative and positive wave number against the frequency respectively. The FQ filtering is one of the most efficient and commonly method that used in removing the unwanted noise from marine and land shortcarriers. Now, let's move to the body of paper. For the first subtopic for body of paper, that is about the main people working in doing this FQ filtering. There are many researchers had done their study in doing this FQ filtering in seismic data processing. For example, Herman et al. In 2017 had done their study on the application of FQ filtering for coherent noise removal in high-frequency shallow marine data, followed by a research study from Kin et al. In 2012, where their research paper is about an effective FQ domain random noise suppression technique applied to a land dataset. And the last one is from Collin and Osazuwa in 2009, where he also did some research on the use of FQ filter in the elimination of artifacts from a shallow seismic reflection data in Zaria, Nigeria. So the main purpose of the research study is mainly focused on the attenuating the unwanted energy such as coherent noise, random noise, and migration artifact. In these three papers, they have used the conventional FQ filtering in conducting the noise attenuation. Moving on to the recent major advances and discoveries. Nowadays, many researchers have discovered more advanced techniques in using the FQ filtering in seismic reflection data in order to enhance the attenuation of unwanted energy. The new advanced method in using the FQ filtering are the FQ domain polarization filtering from Wang and Wang in 2017 and polynomial fitting plus narrow reject band FQ filtering from Duan and Fo in 2019. For the first advanced method of FQ filtering is the FQ domain polarization filtering. The FQ domain polarization filtering can be used to attenuate the ground roll that are time varying while preserving the body wave signal. Ground roll can be defined as the coherent noise where it only exists in the land-based seismic data. As I have mentioned before in the previous statement, the FQ filtering can use to attenuate the various kinds of unwanted energy, meaning that the FQ filtering also uses the same concept of FQ filter. This method is then extend the concept of FQ domain to the TFQ domain and propose a polarization filtering method for the ground roll attenuation based on the TFQ transform. This advanced method will apply four attributes which are time, frequency, apparent velocity, and polarization that will be used to identify and extract the ground roll simultaneously. Generally, the more attributes are considered, the better filter result are obtained. For example, the result of time frequency filtering is better than frequency filtering. Therefore, the ground rule and body width can separate as long as they are dissimilar in one of these attributes. The result indicate that this method can effectively attenuate the ground rule while preserving body weight more effectively compared to others method. Other than that, TFK filtering also was used by Simon et al. In 2008. By using this method, they can remove the unwanted noise from the OBS data without removing other seismic signal. As you can see here, that this is a result of using the conventional FK filtering that they are unable to remove the unwanted energy. When we use the TFK filtering, it can be remove one of the unwanted noise. The second advanced FK filtering is polynomial fitting plus narrow reject band FK filtering. This method can be used to attenuate various coherent noise in pre-state and post-state seismic data. It is present a method of narrow reject band NRB FK filtering technique incorporated with orthogonal polynomial fitting. NRB FK filtering is remove the coherent noise using three aspects, which are velocity, frequency, and amplitude. Other than that, NRB FK filtering can reduce the signal distortion and improve the attenuation of the filter to some degree. In order to minimize the signal distortion, this advanced FK filtering should be done in time and space variant and automatically adapt for lateral and vertical variation in apparent and amplitude of the coherent noise. This technique, also known as slowness adaptive FK filtering. Therefore, by using this advanced method of FK filtering, it shows good attenuation characteristic with minimal distortion of seismic data. As you can see here in the first picture, that the state section with a crowd of coherent nodes that interfere with the interesting reflectors and mask the structural and stratigraphic details of the oil reservoir. By applying this new method, the coherent nodes can be eliminated by using polynomial fitting plus NRB FK filtering. Moving on to the significant gaps between the conventional FK filtering versus advanced FK filtering. Their significant gaps are their domain transform, bandwidth of reject zone, and their procedure, followed by the advantage and also their disadvantages. For the conventional FK filtering, they have FK domain, followed by the TFK domain polarization. Filtering, they use TFK domain, and polynomial fitting plus narrow reject band FK filtering, they use TS domain. While for the bandwidth of reject zone, conventional FK filtering has wide reject zone, same goes to TFK polarization. Filtering also has wide reject zone. However, polynomial fitting plus NRB FK filtering, they has narrow reject zone. For the procedure in using the conventional FK filtering, the state section must be converted first from TS domain to FK domain by using the Fourier transform. Then the undesirable event must be multiplied with the small coefficient. After multiply the undesirable event with the small coefficient, the data must be converted back to time domain by using the 2D inverse Fourier transform. While for the TFK domain polarization filtering, the input seismic data gather must be formed first, the complex signal with radial component as the real part and vertical component as the imaginary part. Then do the TFK transform to separate the arrival time, frequencies, and apparent velocity. Next, design the polarization filter based on the TFK transform to compute the reject zone. And lastly, do the TFK inverse transform and obtain the output data. While for the polynomial fitting plus NRB FK filtering, the seismic data need to review the signal distortion effect by using the FK filter. Then, use the polynomial filtering technique to estimate the accurate instantaneous tip and amplitude of coherent noise event. Lastly, design the narrow reject band FK filtering with polynomial fitting to attenuate the coherent noise. Move to the advantages and disadvantages of conventional FK filtering with these two advanced methods. For the conventional FK filtering, it's better to attenuate the noise while preserving the frequency. It can be applied to preset and posted data, and it can be done in spatially and temporally distinct. While for the TFK domain polarization filtering, it is effective to attenuate the ground rule. The process also will shorten the time. It allows to filter time varying signal and distinguish the signal with the same frequency but must have different time. Can separate the ground rule for other reflection signal when they are overlaid in both time and frequency but must have different velocity. While for the polynomial filtering plus narrow reject band FQ filtering is effective to eliminate the coherent noise. It can be applied to preset and posted data. It could remove the unwanted noise when it is overlapped with the reflection signal, and lastly, it can be done in spatially and temporally distinct. The disadvantages for the conventional FK filtering, where around noise may be produced by applying Fourier transform, and it only can be applied to non-aliased seismic data. The disadvantages for the TFK domain polarization filtering, the operation cost is high and it only efficient to separate unwanted noise when they are temporally distinct. Lastly, for the disadvantage for the polynomial fitting plus narrow reject band FQ filtering, it only eliminates the unwanted energy within the reject zone and it cannot attenuate all noise at all times. Now, move to the current debate for the conventional FK filtering. Conventional FK filtering method can be very effective at removing low velocity regular noise to some degree, although it can be very effective at attenuating the unwanted energy, but it can have limited success because of irregular trace spacing and data aliasing. This conventional FK filtering method can sometimes generate significant noise, distortion, smoothing effect, and artifact due to spatial impulse response mirroring. Other than that, conventional FK filtering must use the fan width not too narrow. If the fan width is too narrow, then large array of non-zero element will be produced. Therefore, some alternative methods have been proposed by many researchers in order to obtain a good result of the seismic reflection data. Okay, move to the current debate on the TFK domain polarization filtering. Normally, TFK domain polarization filtering used to attenuate the surface waves such as ground rule that are often vary with time. Ground rule can be categorized as elliptical polarized, which is easier to separate from other reflection signals such as body wave based on their polarization characteristic. However, if using only TFK filtering, then it's difficult to define a reject zone manually at each time point. Therefore, 1&1 in 2017 has proposed to use the polarization filtering based on the TFK transform. Therefore, by applying this advanced method, the reject zone for the ground rule attenuation process can be defined automatically as a function of reciprocal ellipticity. Below is the comparison result between the conventional FK filtering with the TFK domain polarization filtering. Okay, this is the sensitive seismic data. As you can see here, this is a body phase and this is a ground roll. When we apply the conventional FK filtering, it works well, but not completely and perfectly remove the unwanted energy. However, when we're looking at the remove noise profile, some body phase appear in the remove profile noise. This is because of the apparent velocity of this body phase is close to the apparent velocity of the ground rule. Now, in the figure on the left side, when we apply the TFK domain polarization filtering, it shows that this method can positively remove the ground rule for the seismic reflection data. And in the figure on the right side, that this is a remove noise profile, where the result shows that the ground rule is removed using the TFK filtering without removing the body phase. Therefore, this result has sufficiently indicated that the TFK polarization method can suppress the ground rule effectively and guarantee the body phase does not drop out. Moving on to the current debate for polynomial fitting plus and RBFQ filtering, although this advanced method can minimize the signal distortion compared to conventional FK filtering, but the overlap signal and noise in the FK domain still an unsolved problem in the seismic data processing, even though this method could reduce the signal distortion. This method also needs an accurate apparent date because of its narrow reject zone. Although the researcher has used the polynomial fitting to estimate the instantaneous variation in the amplitude of coherent noise event and then incorporate the amplitude multiplication into the NRBFQ filtering, but it only enables the to filter and remove the noise energy when the noise and signal overlap each other within the reject band of filter. This can be proved by looking at the first figure where there are several diffraction zones of strong coherent noise event that looks like dispersive arc and may caused by the variation from the passing heavy ship. This seismic data was processed using the conventional FK filtering. It can be seen that the state result is still exists strong residual coherent noise due to overlap of the signal and noise. By applying the polynomial filtering plus NRB FK filtering, it only can eliminate the coherent noise in a limited TX window with an arbitrary shape of the seismic section. Last but not least, some conclusion has been made from my study that both conventional and advanced methods have their own advantages and disadvantages. Normally, conventional FK filtering is used to attenuate the simple noise, and advanced methods such as TFK filtering using the polarization analysis is the best advanced method to attenuate the spatial alias ground rule for the body wave that have overlapped in time varying, while for the polynomial fitting plus NRB FK filtering is the best method to minimize the signal distortion, which will prevent the smoothing effect, loss of fine details, mirroring of energy, and artifacts. This type of coherent noise often contaminates seismic signal and severely reduce the signal-to-noise ratio of the seismic data. Therefore, choosing the best and proper technique in eliminating the unwanted energy is a must in seismic data processing in order to preserve the quality of seismic data recorded. Lastly, some recommendation has been proposed for the future direction in choosing the correct FQ filtering in eliminating the unwanted energy. The first recommendation is the unwanted energy can be performed successfully if the correct advanced FQ filtering technique are selected depending on the type of unwanted energy in order to obtain the high quality of seismic data without having any noise contamination. And the second one is the removal of unwanted energy also can be optimized by using the Tau-P domain method instead of using TS domain. This is due to Tau-P domain can distinguish the exact temporal predictability of unwanted event from the primary event. Okay, this is a list of references that I have used in doing this paper review presentation. I think that's all from me. Thank you for your time.